Hello everyone. This is a short recording on the notes that I missed to record in the previous recording. Here we are going to do the discussion about the preference, which is the quasi-linear function. What do we mean by the quasi-linear function? The quasi-linear function means to say is that the utility function is not linear in both of the goods. It is linear in one good and non-linear in other good. So here we can see that u is the linear function of good y and non-linear function of in the good x, because the power raised to the x is half. So if you will differentiate utility function with respect to x, you will not get a constant. That is why it will not be linear in x and non-linear in, it will be non-linear in y x and linear in y. So there's a thing that we need to know, that why do we use this utility function? We use this utility function when there is when we want to consider the demand for the necessities. And here there's one more thing, is that this indifference curve is convex to the origin, because if you will try to find the marginal rate of substitution of this utility function, which is the del u upon del x, del u upon del x upon del u upon del y, you will get the marginal rate of substitution to be 1 upon 2 root x. And you can easily see that as x increases, the marginal rate of substitution falls. So that is why the indifference curve will be convex. Here, due to the indifference curve being convex, we can use a Lagrange. And we will use the Lagrange function, where we will be maximizing the objective function, which is the utility function, given the budget constraint. And here we have written it like that: L is equal to root x plus y, subject to the budget constraint of this. So as we can use the Lagrange function in here, we first differentiate it with respect to x, and then differentiate it with respect to y, and then differentiate it with respect to lambda. So you get first three equations. Now to get the equation of where the slope of the indifference curve is equal to the slope of the budget constant, you divide the equation 1 with equation 2, and you get the slope of the budget constant, which is p1 upon p2, to be equal to 1 upon 2 root x. And when you try to find the quantity, when you try to find the x through this, you will get the x to be p2 square upon 4p1 square, which will be greater than 0. The reason being is that the both the p2 and p1 will be greater than 0. That is why the demand for x will always be there. Now you would like to find the quantity of y. So you can find the quantity of y by putting the quantity x into the budget constant, which we have done here, and you get the quantity of y is equal to 4m p1 minus p2 square upon 4p1 p2. And there is a possibility that y star can be equal to 0, because if 4 and p1 is less than that of p2 squares, then obviously the y star will be negative, and no quantity of any good can be negative. So there is a possibility of y star to be equal to 0, and it being greater than 0. So we can write that a y star is greater than equal to 0, depending upon what is the value of the numerator. So if the 4m p1 is greater than that of p2 square, then obviously the y star will be positive, and so the consumer will be demanding the positive quantity of both x and y. But if 4m p1 will be less than that of p2 square, then the quantity that the consumer will be demanding of good y will be equal to 0, and the consumer will only be demanding the good x. So here we have shown in this way, like if 4 and p1 minus p2 square is less than equal to 0, then the quantity that the consumer will be demanding of y will be 0, and the quantity that the consumer will be demanding of x will will be in such a way that he will be spending all his income onto the consumption of the good x. So what can it be? It will be m upon p1, because if you will divide the all of your income with the price of that good, then you will get the amount of consumption that you can amount of consumption of good x with the given income m. And if the 4m p1 minus p2 square will be greater than 0, then the demand for the x will be p2 square upon 4p1 square, and the demand for y will be 4m p1 minus p2 square upon 4p1 p2. Now, as we know that it is also important for us to find the indirect utility function. How do we find the indirect utility function? We find indirect utility function by putting the demand curve into the utility function, or putting the optimal demand function that we have found by maximizing the utility for the given budget constant into the utility function. In this way, we get the indirect utility function. So if 4m p1 minus p2 square will be less than equal to 0, the demand for the x will only be there, and the demand for the good y will be equal to 0. So the in that way, the indirect utility function will be root of m upon p1, which will be this. And if 4m p1 minus p2 square will be greater than equal to 0, then the indirect utility function, we will be putting the both the quantity of x and y into the utility function that we already have. And in this way we are putting, and by simplification you can obtain the indirect utility function, which is this. And now there's also important for us to find the expenditure function, because sometimes in exams expenditure function can be asked, and it is also it may be asked that to find the Hicksian demand function if we do not know the other method of uh, minimize the expenditure for the given utility. Then you can find the Hicksian demand function by Shepard lemma. So in this case we would like to find the expenditure function. Again, there will be two cases where the 4m p1 minus p2 square will be less than equal to 0. So you will be putting the quantity of x into the utility function, and you will try to find the income as a function of prices and utility. Now if you will differentiate the income with respect to its own price, you will get the Hicksian demand function of good the good with which you have differentiated the income with its price. So the x1 h is equal to u bar square, and x2 h will be equal to 0. And if 4m p1 minus p2 square will be greater than 0, then this will be the expenditure function, and you will differentiate the expenditure function with respect to prices so as to get the demand for the good. Now here's I have already done that in the video, so but I would like to explain it a little bit more. So in here we are having the kinged indifference curve. These type of questions can be asked in the entrance exam. And here the utility function is x plus 2y. Here we can directly see that it is the example of the substitution. It is example of perfect substitution, but the slope in here will be half. And here the consumer will be consuming two if the consumer if we want to if we ask that how much of the good that the consumer would like to sacrifice in order of getting the extra unit of y, so he will be sacrificing 2 units of x in order to get one single unit of y. This is the slope of the indifference curve. And now if we say that the here we will be considering the three cases like P1 upon P2 less than half, P1 upon P2 greater than half, P1 upon P2 equal to half. So if P1 upon P2 is less than half, what it will try to say is that the slope of budget constant is flatter than the budget constant is flatter than that of the indifference curve. So here the consumer will be consuming all of x and not of y. That is why the consumption of x will be m upon p1, and the consumption of y will be 0. And if the slope of budget constant will be greater than that of the slope of indifference curve, it means to say is that the rate at which the consumer would like to sacrifice its would like to exchange the goods in the market will be more than that consumer would like to exchange in his own senses. So in this manner the budget constant will be flatter than will be steeper than that of the indifference curve, and the consumer will be consuming all of y and not of x, and the consumption of x will be equal to 0, and the consumption of y will be m upon p2. And the third case is that of m upon p1 upon p2 is equal to half. So here the consumer will be indifferent in consumption of good x and y. So here we can write the x star is equal to 0 to m upon p1, and y star is the amount that is left to spend on the good y. And here we can write in this way. Now there is another case which is similar to that of the case discussed earlier, which is the utility as utility written as a 2x plus y, and the slope of the budget constant will be the mux upon muy, which will be equal to 2. And here again the slope, if the slope of budget constant will be less than that of 2, the consumer will be consuming all of x. And here it is written. And if the slope of budget constant will be greater than 2, then the consumer will only be consuming the good y. And if the slope of budget constant will be equal to 2, then the consumer will be consuming the x star from 0 to m upon p1, and y star will be the all amount of the income that he is left with to be spending on the good y. And I have discussed all of this in the recording that was uploaded earlier, so you can refer to that. If you face any problem, then you are free to contact me. Thank you.